Hello friends, welcome to Truth of Physics. In this video, I will discuss on the continuity equation of EMT, that is electromagnetic theory. So first in this video, I will derive the continuity equation, and after that I will solve the equation to get the solution, that is the charge density after a certain time t. So you can understand all the things what I am saying. So complete understanding, watch this video till the end. Okay, so let's start. Suppose I have a volume. Okay, I have a volume which is enclosed by a surface, closed surface like this. Okay, now so J is the current density at any surface element, any small surface element in this surface. So the total current flowing, that is the total current which is flowing out of this surface, will be what? The I current, total current will be J dot ds. This will be total current integration. Now this is what? This is the current, that is the flow of charge, which is the amount of charge which is flowing out of this surface, that is denoted by I. And we know that from the local conservation of charge, I can say that the amount, this is what, this is the flow of charge, the amount of charge which is flowing outward. Now this is equal to the decrease in charge within this region. This is equal to the decrease in charge within the region. That is, I want to simply state that I is minus dq over dt. This is what? dq over dt is what? The decrease in charge within this region, which is equal to I. Okay, now it is clear. I think that you have understand and you can visualize these things. Okay, now I is equals to minus dq over dt. So I can be written as this. So integration j dot ds will be equals to minus dq over dt. I can write minus dq over dt minus ddt of rho into dv. Rho is what? The charge density of this, in this case, the charge density in this case. Now using, this is what, j dot ds, using the Gauss Diverges theorem, I can write here del dot j dv is equals to, the volume integral is equals to this, that means minus ddt of rho dv. Okay, integration sign as q is what? Q is equals to rho dv, as dq is equals to rho dv, and q will be equals to what? Integration of rho dv. So I have put this in the term of q, in this place, in the place of q. So this, okay, so it is integration. Now so comparing these two things, these two volume integrals, I can write that del dot j will be equal to minus d rho over dt. Okay, so taking it in this side, I can write del dot j plus del rho del t will be equals to 0, and this is our continuity equation in EMT. Okay, we know that j equal to sigma into E. J is equal to sigma E. This is what? This is the microscopic form of the Ohm's law. Microscopic form of Ohm's law, or you can say that this is the fundamental form of Ohm's law. From here we can derive that V is equals to IR, which is our familiar Ohm's law. Okay, so I have made a video and I will give the link in the description box of that video, a short video of 1 minute. So there I have derived that j equals to sigma E converges to V equals to IR. So j equal to sigma into E, I will put this condition, this thing. Now from here j, if we put this thing, so what will happen? Del dot E, sigma, as sigma is constant, sigma will be taken outside, del dot E plus del rho over del t will be equal to 0. Okay, so from the differential form of Gauss law, which I have discussed already, you can watch that video. I will give the link in the description box. The differential form of Gauss law says that del dot E is equals to rho over epsilon naught. So rho over epsilon naught I will put here. Okay, sigma. So this will be sigma rho over epsilon naught equals to minus del rho over del t Now I will just integrate this, just solve this differential equation. So minus del rho over rho will be equal to sigma dt over epsilon naught. Now, so this will be ln rho by rho naught, but there is a negative sign, so I am okay, the negative sign is taken as if, so ln rho over rho naught will be equals to sigma t over epsilon naught. Now I am removing this, now from here I can write that, rho will be equals to, if ln comes in this side, then it will be e raised to power, okay. So e to the power minus is taken in this side, okay, minus is taken in this side, minus sigma t over epsilon naught and rho naught. So rho is equals to rho naught e to the power minus sigma t over epsilon naught. This is very much important for solving mathematical problems and to understand that what happens to the charge density after the time t. Now from here I can also calculate the relaxation time or mean time. So what is that? All the concepts of relaxation time is same for this concept, or for this, in this case, or in the case of modern physics, okay, exponential decay. In everywhere the concept is same, that is the time at after which here the charge density, the time after which the charge density will be the 1 by e times the initial charge, that is when rho will be equals to rho naught over e, the exponential, okay, e to the power 1 e, the exponential equal to rho naught e to the power minus sigma t over epsilon naught. So from here t will be equal to what? T, so ln e will be 1, I am taking both sides ln, so ln e will be 1, so minus will be just cancelled, so this will be, now t is what? Tau. Now t, in this case the t will be converted to tau, which I am representing the relaxation time or mean time, okay. So tau will be equals to our epsilon naught over sigma. So this is the relaxation time. So in terms of relaxation time I can write this, rho is equals to rho naught e to the power minus t over tau. So this is the ultimate form. So there will be there I can also draw the graph. So the graph will be like this, okay, here is rho and here is time. So I think that you have understood this concept, and this is very important concept for studying the EMT, and in many parts and many branches of physics it is very important to understand the continuity equation. So if you like this video, then share this video with your friends and take care of yourself. Thank you for watching.